This is Module 1, Lesson 10, where we're going to talk about adding and subtracting with scientific notation. There's a few things that you need to know first. I just want you to understand that you're going to be asked to do this without a calculator. That makes this difficult. The state requires that we do this part without a calculator, so we're going to do so. When adding or subtracting numbers in scientific notation, the thing that's very important is the exponents have to be the same. So we're going to need to convert at least one of the scientific notation equations that we're dealing with usually to an exponent to match the other one to be able to add or subtract. Here's an example. Now this one, the exponents are the same, 10 to the third, 10 to the third. So when you're adding, you're not messing with these. You're just adding the numbers in front of them. 2.56 times 10 to the third plus 6.964 times 10 to the third. You add the two numbers in front of the exponential basis, okay? So 2.56 plus 6.964 gives you 9.524. And that's times 10 to the third. Whatever you've got here, times 10 to the whatever power, that would be what you've got back here. See how you're not doing anything with these? Not doing anything with these exponential notation expressions here. You leave it as 10 to the third. You're just adding the numbers in the front. That's when you have the same exponents. See, 10 to the third, 10 to the third. What if your exponents are different? In this case, you've got 4.0 times 10 to the 6th plus 3.0 times 10 to the 5th. Well, you're tempted to just add these and say, oh, that's 7, but you don't know 10 to the what? In fact, if the exponents are different, you're going to have to make sure you change one of those exponents. You convert one of those exponents, convert that scientific notation to a format that will work so the exponents match. You have to have the same exponents for this to work. So you're adding apples and apples, essentially. This is 4 times 10 to the 6th. I need to convert this to 10 to the 6th. Now let's look at this. If we're converting that to 10 to the 6th. We did some conversions earlier in some of our earlier units. I need this to be to 10 to the 6th, don't I? So let's remember LARS, L-A-R-S. To get from 10 to the 5th to 10 to the 6th, what have I done? Have I added or subtracted anything? I've added 1, didn't I? If you add, remember this thing goes this way. Left, add, right, subtract. To get from 5 to 6, I've added 1 on that exponent. When I add, I move my decimal left, okay? So see, you move your decimal left one place. This 3 times 10 to the 5th is equal to 0.3 times 10 to the 6th. I've just expressed this exact same scientific notation, but instead of being 10 to the 5th, I need it to be 10 to the 6th. So I'm having to move the decimal to do that. Now that I have these both with the same exponent, all I need to do is add the coefficients that are in the front, the numbers that are in the front. 4.0 plus 0.3 gives me 4.3. See, it's not 7. 4.3 times 10 to the 6th. Is this in scientific notation? Yes, it is, because this number is either greater than or equal to 1, but less than 10. So let's try a few of these. In order to add or subtract numbers with written scientific notation, they have to have the same exponent. We've said that. Use LARS on one of the numbers to adjust the exponent so that it's the same as the other. Add or subtract the numbers Keep the common exponent. Use Lars again to adjust the decimal if needed to ensure it's in correct scientific notation form. Okay, so let's try this one right here. Let's look at our scientific notation. Do we have the same exponents? No, we don't. We need to convert one of them. Up here we said, let's always convert the smallest one. Move the decimal on the smaller number. That's usually easier. If you look at these, 5 times 10 to the second is a smaller number. Look at your exponents. That's your smaller one. So let's keep our 8 times 10 to the third. And we're going to convert this one to 10 to the third. We've got 5 times 10 to the second. That would be equal to what times 10 to the third? To go from 2 to 3. To get from 2 to 3, what have I done? Added 1. Lars tells us if we add, we go left 1, right? Decimal's understood to be here, so I would move it one place over. That's 0.5 times 10 to the third. So let's set this up here. I have 8 times 10 to the third, and I'm going to erase this a little bit so we got a little bit more room. Okay. Eight times 10 to the third plus, because we're adding these two, 0.5 times 10 to the third. Where'd the 0 come in? You know you can put a 0 in front of the decimal as a placeholder. Now let's add what we've got. 8 plus 0.5 is 8.5. And remember, we add or subtract the numbers and keep the common exponent times 10 to the third. Is this in scientific notation? Yes, it is. Okay. Let's try this one. We're subtracting now. Okay. So let's take the smaller one. We know -2 is smaller than -1. Let's convert this to -1. 4 times 10 to the -2. We're going to convert that to something times 10 to the -1. Let's look at our exponents and use Lars. We've got -2, and we're trying to get it to -1. What have I done? To get from -2 to -1, I have added 1. If you add 1, Lars tells us if you add, go left. So we're going to go left 1. This is 4 times 10 to the -2, so I would go left 1 place. That would give me 0.4 times 10 to the -1, or 0.4 times 10 to the -1. Now let's set these up. I've got 8.1 times 10 to the -1 minus 0.4 times 10 to the -1. Let's subtract. I'm going to borrow 1 here. So I've got 11 minus 4 is 7. That gives me 7.7 times 10 to the -1. Okay, is that in scientific notation? Yes, because 7 is both greater than or equal to 1, and it's less than 10. Let's look at number 5 here. We're also subtracting. Now we've got 6 and we've got 4. Here's our smaller one on the exponent. Let's convert it. 3 times 10 to the 4th. I want this to be something times 10 to the, 6th. Okay. To get from 4 to 6, what have I done? To get from 4 to 6, you add 2, right? Lars tells us that if we add, we go left. So I need to move this decimal 2 places to the left. 1, 2, that'd be a 0 there, right? So that would be 0.03 times 10 to the 4th, okay? Or 0.03 times 10 to the 6th, okay? Now let's subtract. I've got 5 times 10 to the 6th. See, I left myself some room. It's 5.0, right? And I'm subtracting minus 0.03, see, times 10 to the 6th. Okay, let's put some decimals behind this 5 because those don't matter. Now, we've got, think of it this way, $5 minus 3 cents. Wouldn't that give us $4.97? Well, let's just see. First, I need to borrow 1. I don't have anything to borrow there, but I do here, 4. And I've got a 10 there. I need to borrow from that 10. And that would give me a 10 here. 10 minus 3 is 7. 9 minus 0 is 9. 4 minus 0 is 4. 4.97 times 10 to the, what is we got? 10 to the 6th. 4.97 times 10 to the 6th. Okay. Let's look at number 7 here. We're adding. Okay. Let's add. If we look at our numbers, we've got a -1 and we've got a 2. Okay. Our small one is this one. 1.4 times 10 to the -1. And I'm trying to convert that to something times 10 to the 2nd power, right? To get from -1 to 2, what have I done? I add 3, right? -1 plus 3 is 2. So if I'm adding 3, Lawrence tells me I'm going to go 3 places to the right, okay? I've got 1.4, 3 places to the right would be 1, 2, 3, okay? So this would be $1,400 times 10 to the 2nd. I'm sorry. Let's do this part over. We got on the wrong one there. To get from -1 to 3 to 2, we're adding 3. That means we go left, okay? So 1.4 times 10 to the -1 means that we're going to go left 3, okay? That would be 1.4, 1, 2, 3, 0.0014. Sorry, I was going the wrong direction. 0.0014, okay, times 10 to the 2nd, all right? So let's just set this up. I've got 5.1 times 10 to the 2nd plus 0.0014 times 10 to the 2nd. That would give me 5.1014 times 10 to the 2nd. Okay? Now, that gives us several addition and subtractions that we've gone over. Let me look at a couple of these. I wanted to do one word problem with you. In 2013, the national debt was approximately 1.8 times 10 to the 13th dollars. In 2014, the debt grew by 3.3 times 10 to the $11. Find the total debt at the end of 2014. Give your answer in scientific notation. So what we're doing is we're adding 1.8 times 10 to the 13 plus 3.3 times 10 to the 11th. And we're adding. We need to convert this small one here. 3.3 times 10 to the 11th. And we want to convert that to something times 10 to the 13th. When I go from 11 to 13, what do? I add 2. Lawrence tells me if I add 2, I go left, okay? So I need to go left 2 on this one. It would be 1, 2. That would give me 0.033 times 10 to the 13th. Okay, so now let's add this. 1.8 times 10 to the 13th. See, I left myself plenty of room to put this other in. And 0.033 times 10 to the 13th. I would add these, and I would get 1.833 times 10 to the 13th. Notice you just simply keep the exponent you've got here. Okay, I'm going to give you a chance to work on some of these yourself. Remember, no calculation.